It was like little fatbergs of XML, wasn't it? Like,
I can see from your notes you're a big fan of SO.A.P because the notes say a stepping stone of awfulness.
yeah.
Hello and welcome to Offscript. My name's Josh Nesbitt and I'm joined by James Hall, and today we're going to be talking about modern API design.
Cool. So today we're going to be talking about API design.
Yeah, so I guess it probably makes sense to start with what is an API?
An API is an application programming interface, and it's basically like the glue between different applications.
Yeah.
It's the way that you talk to another application and the publicly exposed documentation and yeah.
Yeah, I think it'll be good during this kind of chat to define what an API is and isn't. I think it's often slung around as a kind of term for many things. So I guess it's good to define what an API is and kind of how they came about, I guess.
Yeah, well, they're not new things.
No.
So they've been around since the 60s in a certain sense. So you could always call different bits of functionality without knowing the actual underlying implementation.
Yeah.
So you'd have a function name and you pass some stuff into it. And that was kind of like the early API sort of work that went on. But yeah, people have been doing that for a long time. So
Yeah.
you'd have syscalls that would do certain stuff with the screen or the printer or whatever else, talk to a serial port. And yeah, they started out pretty basic.
Yeah.
And then we sort of move over into the 70s and 80s, and you're starting to get these remote procedure calls. So it's where you have connected computers, so over a network, and you can call bits of code as if they were part of your code base.
Yeah.
So you basically just call a function, pass some parameters into it, and you don't have to worry about it being over the internet.
Yeah.
It just works, which kind of caused a lot of problems.
Yeah.
Because people would then start using the same tech for local calls, RPC calls. So you'd end up not really knowing where the security boundaries were. And the old school internet is all like gentlemen's agreements, like we trust that there aren't any bad actors, and
Yeah.
like the whole way DNS works is insane. But it's all very much like, oh yeah, everyone's a good guy on the internet, or girl, sorry. And Microsoft really gave RPC a bad name by just wanging everything in there, and people just went to town on it.
Yeah. It's a real shame because if you think about the developer experience for RPC, actually it's quite nice. You know, there's very low overhead to calling remote services versus local. But as you said, the opaqueness of not knowing what's going on behind the scenes is quite tricky.
Yeah. So then people started thinking a little bit more. Well, yeah, there was Corba, COM, DCOM, all those kind of things that for distributed calls. But it was really hard to get good interoperability. You had to have similar programming languages on each side, like the caller and the callee would both be written in C or Java or whatever. And it was really hard to get sort of good interoperability. So a load of smart people got together and they invented the world's most awful thing, which was S.O.A.P. And if you're not familiar with S.O.A.P, this was a real good go at making something they thought would be good. So you'd have a beautiful XML definition of what your API is, and then you'd have these big fat payloads with all sorts of extra fluff that you didn't need. And you would really struggle doing this bare. You'd have to have some sort of awful S.O.A.P library to interact with it, and then no one would be fully compliant. And yeah, it was just an absolute nightmare. I don't know if you've ever worked with S.O.A.P in the past.
Yeah, it's an interesting idea, I was going to say, because what they did is they abstracted a lot of the dangerous parts into definitions of things, into pure kind of syntax that wasn't able to execute without the kind of wider system, which in itself is quite a sensible idea in terms of trying to remove people doing nasty things. But what that meant is you had a really verbose document for everything you were trying to do.
Yeah. And because it threw away anything to do with the internet. It threw away all the good stuff like cache headers and anything that was good, and just made these big fat blobs of. It was like little fatbergs of XML, wasn't it? Like,
I can see from your notes you're a big fan of S.O.A.P because the notes say a stepping stone of awfulness.
Yeah, but I think a lot of the time to make something good, you have to make something truly bad.
I think so. I mean, I think if you're looking positively on it, it was an evolution of a more dangerous time, and it kind of helped pave the way for a lot of things in the future. So I think often you have to do things wrong to figure out how to do them right?
Yeah, so it was heading the right direction. It was packets of information traveling across the internet. It was separate from the programming language. It was abstracted away, and you could serialize and deserialize it in any language, which is on the right tracks.
Yeah. But XML is verbose by nature, I guess, in that sense. So.
Yeah, and then the Restful API started to sort of emerge. But before it was called Restful, it was just people going, "I don't really like S.O.A.P, but should we just expose this XML document?" And then people invented stuff like RSS, which was just a simple XML format.
Yeah.
And people going, actually, it's not too bad. And people started to go, well, we could actually use the HTTP verbs on top of this. So get and put and post and actually make them mean different things.
Yeah.
And we were getting there. And then suddenly JSON happened.
Yeah.
Because people were like, XML's pretty cool. And then it was Crockford, wasn't it? It came up with the idea of a subset of JavaScript, which is just,
Yeah, JavaScript object notation, isn't it?
Yeah.
So, I guess he was sick of XML and wanted a more kind of native language to communicate, not language, I guess, format.
Yeah,
kind of language.
Like a markup language, I guess, yeah. And the cool thing was, it was all at this exciting time where we were all like getting to grips with XML HTTP request, or AJAX. And we were getting very excited about loading in data into pages without reloading the whole page. And JSON just sort of fit the mold.
Yeah.
And then I think sort of REST, public API started sort of launching around sort of 2005, like as proper, this is a nice API. So the Google Maps API was a biggie.
Yeah.
And then Yahoo came up with their Pipes product.
Yes, I remember.
Where you could sort of, it had a cool thing where you could actually drag and draw little pipes to join things together.
It was quite cool. It's kind of like an early IFT kind of style thing, I guess, in terms of how you connected stuff.
Take an RSS feed, do some stuff to it.
Yeah, it was cool.
Bugging out as JSON.
The thing I liked about JSON is obviously if you were writing JavaScript anyway, you already knew it. So that was quite nice.
Yeah, and you just paste it into your console.
Yeah.
Well, at the time it was Firebug.
Yeah.
They didn't have a built-in console in your browser.
Yeah. REST was RESTful interfaces and everything were kind of my primary interface with APIs at that time. Like kind of most of the things that I was working with REST, Rails added loads of REST support quite early on in the days of Rails. So it became the way to build APIs for me, which was great because it's quite quick to get things moving.
Well, in Rails, can't you just return like a hash and then it just turns it into JSON for you and stuff? Yeah,
and then there's loads of nice kind of syntactical sugar in Rails to make working with REST APIs really nice in the roots. So as you mentioned, you kind of HTTP verbs and everything was all just really nicely supported out of the box, which was good. And
then people just blindly returning the whole active record with the secret fields on.
That's the one. Here's your hash password. Knock yourself out. Yeah, exactly.
We've all been there.
So that's good. So,
but there's a bit of a sort of renaissance, if you like. People getting excited, building cool stuff, and then everyone started to grow up a bit and go, right, actually, there's good and bad ways that we've learned to do this, and because my very, very early APIs were awful. Like they'd change on a whim. There wouldn't be any sort of logical structure to them. things like Rails and that way of doing things sort of made you break it down into controllers and actions at least.
Yeah, I think initially it's kind of like the first thing is, how do I get this data out of the database or something like that, or how do I perform an action? I don't think you really think about the surrounding experience to achieving that. You just kind of like, give me the data or whatever else.
Yeah. The problem is when you introduce other people, as tends to be the case in life.
In every walk of life.
So although APIs are meant to be called by computers, they need to be understood by humans first.
Yeah.
Otherwise, it's pointless. So focusing on the end user and who's actually using it. And I quite like this. I think we've talked about this in previous podcasts, but like the documentation-driven development, where you write your README first, basically, and then does that make sense? And then stub out the actual endpoints.
I often followed a similar route for application routes because there's a really great article. I can't remember who wrote it, but it was about your URL as an API. In terms of designing that URL structure for how you interact with that API is very similar to that documentation, isn't it?
Yeah, definitely. Once you've written it out, you want to get it right. So a cheap, quick README first is going to be really good, because if you put an API out there, people start using it. Changing it is awful.
Yeah, or you're going to break loads of stuff.
Yeah. Move fast and break things.
which often happens. Certain industries are worse than others.
So we've got a client at the moment. We're just doing a bit of an audit on their thing, and they have the very first API that they launched years and years ago, and they have to still support it forever. And you have to then, if you re-architect everything underneath, you have to make another layer to support that API.
It's tricky, isn't it?
Yeah, and I think companies like Stripe have done it really well, where they sort of version it by they've got date versioning as well, haven't they?
I think I can't remember because I haven't used the actual API directly recently, but I think they actually had the version number in the root of the API path as well. Because that's something I learned probably similar to you quite a few years ago. Add versioning from the start, even if you never get off version 1, because often you never increment it that often. But put it in there, because if you need to introduce breaking changes, you don't want to knacker everything at once.
Yeah, that's it. That's just made me think about a project that we're starting in the minute that hasn't got that.
Well, there's lots of...
oh, God, I'm going to have to change it.
Quick to do.
Add that to the list. But I mean, I guess the problem is with like internal APIs as well. Like they don't see as much care and attention maybe as like a public API. Like if you're building both the front and the back end, and you're building it in tandem, you might be a bit more fast and loose with it. But I think it's better to have a little bit more formality around it.
I mean, I guess it's worth mentioning here that we're primarily talking about web APIs here. Obviously, APIs can also be related to, you just saying internal there made me think about it, but APIs can also be the way that you interface with a library or anything like that.
Well, that's true. The internal structure of an application, figuring out what's publicly callable by the rest of the app is pretty important. And
if you're like me and you dig around code bases, then you're going to, React's a really good example of this. There's formal APIs for you to work with React, and then there's like, if you dig underneath, you can be like, oh, but if I do this works.
Yeah. But
it's an unofficial API that may break or change at any time.
Yeah. Well, the React API and the way that things work is really good, because it makes it very difficult to shoot yourself in the foot. So you can only pass data around in certain ways.
Yeah,
you have to use a state store, or you have to pass it in through params. Quite difficult to do the wrong thing. And then if you want to render just bare HTML, they have that really well-named dangerously set in HTML or whatever it's called.
Yeah,
and you have to write the word dangerous, which we've talked about before, which I think is, although it looks bad, it's meant to look bad.
Yeah, it's meant to feel wrong, isn't it?
Yeah. If you feel like you're doing a bad thing and it's bad, then you're going to be extra careful.
Yeah, and the same applies to web APIs, right? You're, like you were saying, documentation-driven development, or thinking about the user experience, the developer experience. If you make it really easy to do something right, then that'll be the way that is adopted. If you make it really difficult, people probably find really creative and interesting ways to use your APIs to get what they need.
Yeah, absolutely. So moving on to Slack. So they launched a hugely successful developer platform. Everyone was building their own apps on top of it.
Yeah.
But the very first version that they released was it's basically the API that they'd built for themselves.
Oh, right.
Because they were originally an agency built the app in PHP, MySQL, and they used something for their messaging in some Java thing.
Yeah, I remember. Yeah.
But to rewrite the front end, I think it was a big pile of jQuery and
I think
CSS
it was, yeah.
and stuff,
Yeah.
which is how you would quickly build a thing at that time.
Yeah.
Absolutely. And they were like, we're going to have to untangle all this. So they built a really quick API for themselves. And they were like, actually, we could expose some of this to third parties.
Yeah.
But then there was no like permissions or anything. So if you are an installed app, you get everything.
Yeah.
You can see in the channels and stuff. So, yeah. So they had a bit of a hard time sort of re-architecting that and moving everyone away from it. Whereas GitHub API, they started off with the nice REST APIs.
Yeah.
And at the time, they were like, this is really lovely. But then they just kept adding more and more fields and more stuff. And these payloads just kept getting bigger and bigger and bigger. And when they started to rethink their external third-party API, they were like, they don't need all this data. So they actually switched across to GraphQL, which I think is an interesting idea, which we've talked about in the past, especially when you're not able to talk to the people that are consuming your API or know all the use cases. It's a way overkill if you're just building an app for yourself.
Yeah, I think so. I guess with GitHub, especially because a lot of the responses were huge, right? You're getting all the data for everything you're requesting. Repository payloads were growing quite quickly, if I remember at the time, because a lot of the commit data and all that sort of stuff was pretty hefty. And I guess it's a developer platform as well. I guess the interesting thing there is it's specifically a developer platform. Like the kind of apps that are going to be integrated with it are very different to, say, Slack, where they had quite a rich add-on architecture, but it was quite self-contained in that way. Like I don't think you have as much access to Slack's API as GitHub's. Like I don't think you can create lots of users and manage the whole organization through their API. Can you now?
Oh yeah, I don't think you can actually.
So whereas GitHub was like, here's our entire platform, and you can do it within your own organization or space. But you could do pretty much anything on there, I think.
Yeah, it's pretty flexible, wasn't it? I mean, the GitHub API, the GraphQL one that they developed for external devs, they loved it so much that they ended up rebuilding their whole front end using that. Which is pretty cool.
I really like GraphQL, especially for reading data from servers. GraphQL is obviously very good at aggregating data from different services as well. If you building those APIs, I've never loved the mutation side of GraphQL.
No,
it feels really clunky. That's one thing I love about REST. The kind of verb way of interacting with the API made a lot of sense to me in terms of those common operations like create, read, update, etc. Mutations in GraphQL feel a bit heavy-handed.
Feels like a bit of an afterthought to me.
Yeah, because it still feels like you're reading data, but actually you could be doing something really destructive.
And I guess the other issue with GraphQL is performance. You don't know how much data people are going to request or how nested
or where from.
Are. It might take 10 seconds, 30 seconds, might take some of your APIs down for a bit.
I mean, caching's historically quite hard in that way because a lot of the payloads are wildly different. It's quite hard to look at caching patterns in GraphQL services based on, especially with something like GitHub, where I imagine there's so many different use cases for those integrations. Yeah,
because you have to basically compose an entirely new request for people. Whereas with REST, you could, if people were looking for exactly the same thing, you could serve them the same thing.
Yeah, I remember in the kind of second iteration of it in Rails, you could be selective. You could be like, only give me these fields, and you started to see that kind of bridge in between where GraphQL was starting to come in.
Yeah, and that must have been the route that Facebook explored when they were building the mobile apps. Because there was that Open Graph API where you could go, give me this field, this field, this field. But they chucked it all out and invented something completely new.
So what other good examples have we got of APIs that have kind of really worked well?
Well, the two that mainly stand out for me are Twilio and Stripe, because the API is the product. That's their whole bag. So Twilio, although they have been sort of going into the UI space recently, they were traditionally it was I want to send an SMS and I want a really nice clean API.
Yeah.
It's kind of a breath of fresh air, both those products, because I don't know if you've worked with any sort of lesser known payment gateways, but they're always awful.
Yeah, I've got the burns from Braintree.
But like they're half documented. They don't work the way they expect you to. They ship you a zip file with some PHP 4 in it and hope that you'll manage to cobble it together.
Yeah,
and it's just like help. Whereas
the thing about that is it's one area where you want to be like, I know this works and I know why. Whereas some of it was very much like the abstraction wasn't there for you achieving the task you came to achieve. It was kind of like, well, you've got to do the authorization and do this and that and say the card detail and whatever. It's a bit clunky, wasn't it?
Well, and then worse news came when 3D Secure came along and everyone had to patch that into it.
Yeah.
So Stripe was really one of the first things that I saw and thought, fucking hell, these guys have got it right. Not only was the marketing site beautiful, but it didn't hide the techie stuff either.
Yeah.
You were a click away from right into it. This is how it works. This is the nitty gritty.
Yeah.
Before you don't have to sign up. Like some people hide their dev docs, and that means, by the way, that their product is awful.
Yeah.
So, but Stripe were like, no, we're proud of it. You come have a look.
Yeah, if there's a call us to get a demo page, you've got a problem then.
Yeah. We by call 3, we'll set you up with an account where you can log in and then you can peek under the hood.
Yeah, we'll send you a PDF with the docs in it. Yeah.
And hopefully by then you're too invested to back out.
Yeah. I mean, Twilio was amazing. Both Stripe and Twilio simplified quite a complicated industry at the time. So telecommunications in terms of any sort of APIs was an absolute shit show.
Yeah, SMS APIs were awful but most of them were flaky as hell because people were using it to send out spam.
Yeah.
Notably, some good ones. One in Leeds, AQL's API was pretty good.
Yeah.
But yeah, everyone else's, it's like upload this CSV in this weird format and then we might send them out.
No one wants to integrate with that legacy hardware either. Like some of it's really fiddly.
Yeah.
But yeah, Stripe, it's interesting recently. They've gone the other way where now there's loads of no-code options for Stripe.
Yeah.
So they've gone the other way where they've really got developer confidence through that initial product.
Yeah.
And now the devs are like, yeah, but the no-code's really good and easy.
Yeah. I've seen a few startups recently where you press a button and you direct it to a Stripe hosted page, even though they don't even bother putting a logo in or anything. And it's like, I don't mind because it works and it's really nice.
Well, also, I think Stripe is synonymous to a kind of trust as well.
Yeah.
They've done a really good job with building that brand. Developers are quite hard to convince a lot of the time. So the fact that you got devs on board selling this product into companies is powerful.
Absolutely. And their rates are negotiable if you've got enough volume as well. I know a lot of people are like, oh, it's really expensive. It's not too bad.
It's not. You just need to, if you're spending a lot of money through Stripe, you need a good account exec or something like
definitely.
that to look after you. But yeah, so Twilio and Stripe, fantastic examples of APIs there.
And then there's loads of other stuff that's sort of loads of patterns that we were doing that didn't have names yet. And one of those was webhooks. We were calling them callbacks and stuff. Like I remember early PayPal integrations. I shudder to think how awful those were. But you'd redirect the user to a nicely branded I say nicely branded. PayPal looked like ass to begin with, didn't it? PayPal page. Put your deets in, and then to verify, they would send something to this other URL later to check stuff. And that was sort of like early webhook, but then it sort of became a bit more standardized. People were like, well, actually, you need to sign it because it could just be from anyone, and it's all got a bit more standardized now, hasn't it? Yeah,
that which is welcomed because I remember a lot of the early. There's loads of really interesting times with webhooks as well. I used to build a lot of them on Heroku until Heroku became awful. But the problem with that is that if they're unauthorized and authenticated, you've got bots just crawling all these webhooks. So there's very much a need to wrap authorization and authentication around them pretty quickly.
Yeah, definitely. Some of the challenges we have with webhooks is local environments. And I think the best sort of get out of jail free card for me is ngrok.
Yep.
Get an ngrok thing. I don't know if you've not used it before, go get it now. But you can basically make a public-facing URL for your local environment.
Yep.
Which sounds terrifying, but it's not too bad.
Yeah, ngrok's it's great, and a lot of the modern, like I think Netlify might have some sort of tunneling in that way, where you can preview local things on the web these days and all sorts.
Right, nice.
But the first interaction with something like that for me was Finch, which is what our pal Nick Payne made. Sadly, isn't around anymore. But it was a really nice product, lovely UI on it.
And it had some magic beans in where it made things like dodgy WordPress installs and other things just work out the box by passing hosts in and all sorts of stuff. And a little Mac toolbar as well.
Yeah, it was a really lovely app actually. But I can see why that would become a nightmare to look after.
Yeah.
But yeah, so ngrok's is brilliant. It definitely helps with a lot of that sort of previewing local things.
Yeah. And then, before WebSockets sort of came about, we were doing some pretty awful hacks with like basically long-running HTTP requests, and you sort of flushing the data.
Yeah.
So I remember building like a live chat prototype. It must be like 17 years ago now. And yeah, you would just have one request go out from the browser, and it would just wait.
Yeah.
And then you would from the server end, you'd just flush some data through,
but never close the connection. Basically,
never close the connection. Yeah, it's like, oh, it's live, which is great. And I think people come up with various names for it, but it was basically a kludge.
Yeah, I mean, before that, you were doing long polling as well, like all that sort of stuff.
Yeah,
which I guess is similar. But
yeah, well, you could do in early browsers. The best thing to do was one request out, wait until you had some data to send, and then flush once and end.
Right.
For browser compatibility, but then some browsers were able to read the stream in flight and things like that. But yeah, if you were doing IE6, you'd just wait for the whole request to come back, but slowly, which was. And
then you had, I don't know if you ever did the kind of consistent polling where you just do like markers of last time that you requested something and trying to do the delta, and oh god, it was awful, wasn't it?
It was. Just secretly refresh every 5 seconds and take your server down a bit.
Yeah. Pusher came along though. I don't know if you use Pusher much.
Yeah, I love Pusher.
Fantastic.
I used it on the talk on Tuesday.
Oh, nice.
I knocked together basically a type form where you type an AI prompt in, and you can do type form to Zapier to Pusher.
Nice.
That's like a few clicks.
Yeah.
And then in the front end, just grab the prompt. I actually did a bit of a hack because there's no API for Dali yet.
Oh, right.
So it drives a testing framework, Puppeteer, to drive a browser to put the prompt in secretly in the background, grabs the images out, puts it back in Pusher.
Nice.
And then out. But that's like, you can knock that together in a day and it's not too bad.
Yeah, and that's a good sign of how far we've come, I think.
Pusher's great. If you haven't used it, it's basically serverless WebSockets before the word serverless was invented.
Yeah.
But you'd have a Rails app, and I think to have a host for WebSockets in Heroku was a bit of a faff because you have to have a long running process.
Yeah.
And it wouldn't work, load balance and all the rest of it. So you just grab a Pusher account. It was like a little add-on, wasn't it?
Yeah.
You just add it onto
just add it on, and it just worked.
Yeah. But would still recommend Pusher to this day.
Yeah, we used it on a project that we worked on, actually, for the NHS. We built a big learning platform for them. And as part of that, they had these big discussion rooms. So for all the programs where you're learning, going through learning content, it was an area for all the attendees to discuss that content and get help. Before Pusher, that would have been a nightmare to build. But we managed to get it out the door in like 3 weeks, I think, or something.
Nice.
Really, really good. Yeah, so the benefit of Pusher is just the dev experience was amazing.
What I love about Pusher right from the beginning is the way they design the API and the way that they design the sort of onboarding page.
Yeah.
So you pick what language you're using at one side, pick which language you're using on the other side, and you can basically copy paste into your app.
Yeah.
And go.
Yeah, it was
basically
amazing. You especially with the JS library, because they'd literally generate the snippets for you. So, you're going to read from you're creating a discussion forum or something.
Yeah.
Here's the code. Here, start off with this and then see where you get to.
Yeah. And if you if you've got a public API and you can get someone going like that, definitely recommend auto-genning their little snippet to bob in.
100%. Because if you're giving them code to start integrating with an app, if that's in a pull request or ready to go, they've bought your product already.
Yeah, exactly. Yeah,
yeah.
You want the dev to fold it into the code before it's had proper approval from the company.
We need to get the billing sorted for this because we're now built.
We're over the free limit.
That's exactly how it worked. We push it for me actually.
Yeah. Oh, well, they had the free plan that it would go for a bit, wouldn't it? And then it'd expire, and then the app's broken.
Yeah, you'd be like,
quick, get the credit card out.
yeah.
Don't need salespeople if it just breaks the app.
Yeah.
Push a really good example of all that sort of stuff.
So just thinking about kind of API functionality and kind of things that you should consider when building good APIs. So, webhooks and everything, REST, RPC, all the history is really interesting. But if you're building a modern API today, what sort of considerations do you need to make?
Well, the main thing you need to think about is caching and rate limiting. So people will and can abuse your APIs. So you can use things like CloudFront, API Gateway, things like that. You can stick things in front of your API that just make it infinitely more resilient. If it's a public API, it doesn't need a key or anything like that. Let's say it's just some data like an exchange rate, for example. You could just put a CDN in front of it. But a lot of things have come out recently around sort of standardizing rate limiting. So setting certain named headers so that libraries know when to back off and not sort of keep trying your API. So if you have let's say you have, I don't know, a products API and you've got 1 million products, and some one of your consumers wants to go and grab everything for some reason. The nice use of a rate limiting header means that the library will just chunk through at the speed that you want it to. So you can plan for all the capacity that you'll need.
Yeah, because a good example of that is if you're paging through loads and loads of records, it could seem quite DDoSy, I guess.
Yeah, definitely.
It's interesting that because in the early days with rate limiting, certainly from my experience, you'd use something like Redis, maybe as like a API hit cache or something like that.
Yeah, definitely.
Where you'd start to try and understand account usage per authorization header or something like that. Now we've got really interesting trends happening where you're seeing a lot of this moving to the edge. So Cloudflare workers, for example, loads of baked in functionality with things like that where Cloudflare is obviously amazing. It's half the internet by now anyway, which is fantastic. But yeah, I think it's interesting seeing a lot of these things, especially that X rate limit header and stuff being standardized is huge for developer productivity. Yeah,
definitely. And the good thing about pushing stuff to the edge is your edge worker either is like Lambda at edge if you're using AWS, but a lot of people are using Cloudflare, aren't they?
Yeah.
You can get that to do the authorization bit and go, yep, they're good. And then the next layer down is a cached response.
Yeah.
And then you're basically not having any performance hit for having an authenticated API.
Yeah, we're definitely seeing that kind of layered approach to building apps where some of those things are abstracted away from the app completely.
Yeah, definitely.
Netlify, I know I mention it a lot, but it's a great platform. They've got lots of great kind of additional functionality to wrap around your app, around authorization, plugins to certain services. It's quite a nice pattern.
Ace. Yeah, definitely.
Because you always end up with the same logic in all your apps, don't you? Yeah. So it's nice to not worry about that where possible.
Yeah, definitely. We did a lot of work with sports stuff and like scorecards in the past, and we'd basically do it in the simplest way that we could make it work at the time, which was polling. And one of the things you have to avoid doing is if there's an error, the devs goes, oh, there's an error, we'll just try it again. And what that does is if there's hundreds of thousands of people watching a live stream and your server has a bit of a wobble, it will then get attacked by all those clients. We learnt this the hard way, by the way.
This is a matter of experience.
You can't spin them up quick enough to do that. So there's a lot of good libraries you can use which have exponential backoff built in.
Yeah.
So if you get a 500, you shouldn't try immediately. You should try in 10 seconds and then 20 seconds and then 40. You'll see it. You used to see it when Google Mail used to go down all the time. like you'd have a little counter at the top, how many seconds, and you'd see the number keep going up and up.
Yeah, especially if your kind of infrastructure is self-healing in that way. You just need to give it a moment just to stand back up again.
It just needs a bit of moment to breathe.
Yeah.
People are already frantically refreshing. You don't need your code killing it as well.
Yeah, absolutely.
Yeah.
Yeah, so earlier on, rate limiting, exponential back off, all those sorts of things is really good. But the most important thing, I think, is documentation. You mentioned it earlier.
Yeah, absolutely. So what is design if you haven't documented it? It's just, it's not designed at that point, is it?
That was a very kind of
You thought it was going to go deep there.
I thought you were going to go a very thought leader, and I was quite concerned.
No, I'm going to bring it back down to earth. But we talk a lot about API documentation at Parallax, and it varies from project to project, but the best thing has been sort of Swagger and Open API. If there's a way that you can automatically generate that from your code base,
and it's in sync with your code base,
then do that. Some of the energy company stuff that we worked on, one of our devs who leads at the back end of the engineering team, he'd actually written some code where if you add a new endpoint to the application and you haven't documented it, you can't deploy it.
Nice.
Which caught me out because I was just trying to sneak a quick endpoint in there, and it was like, nope. And I'm like, that is correct.
That's brilliant. Good. That's a great idea.
Yeah, I really like that on that project. Obviously, each project, each team's going to be different.
Yeah.
But it does stop people like me going in as like, quick. I'll just quickly add this endpoint. Oh no, it's not in the Swagger definition.
Yeah. That's great.
And then you have to document it, which I should have done anyway.
One rule for you.
Yeah. But you can do the bare Billy basics, like this is the endpoint. But really, you should be showing example inputs and outputs, multiples. Some sample code in there would be good. Just basically, if you've got other people that aren't using your API, you have to assume no prior knowledge whatsoever.
Yeah.
They don't know how your code base works. They shouldn't have to.
No, sometimes you don't even know how your code base works.
Well, exactly. If these endpoints need calling in some magic order, you've probably done something wrong. Which you'd often find in a really dodgy API.
Yeah.
But there's not meant to be any statefulness in these APIs. Ideally, you're not really. They're meant to be like one hit. So it does a thing. It should do that thing. It shouldn't need any.
Yeah, I mean, it's literally called state transfer.
Yeah. Just make it as simple as you can, and just document. If there is any weird stuff, just document it.
Yeah, I think one of the things that I really love about Swagger and Open API is it's a really good tool for teams to communicate with as well. So whether they're users of the API or not, authoring documentation like that or using Open API as a common format to communicate how things should work is really powerful. I've often used it when taking on a new code base. Reading the Open API definitions is a really good way to get up to speed with what the intent was of the author of that API. So you can try and stick to that intent. It's really powerful. There's loads of really good tooling around it. I really like the format, the YAML format of defining everything. You can do some really clever YAML tricks to reduce repetition and all that sort of stuff.
Nice.
But yeah, it's great.
Yeah, you can sort of have a little fragment that you re-reference again and again, can't you?
Yeah, really good.
YAML, I've got a love-hate relationship with. I just find it sometimes a bit awkward to deal with, but it's better than a big XML doc, isn't it?
Yeah, I think my preference would still be like JSON, YAML, XML, in that order. If I had to rate my favourites.
What's your favourite markup?
But I do like YAML because I think I'm also conditioned to it. Rails uses YAML and Ruby uses YAML quite a lot in a lot of libraries, but I do quite like the syntax of it. I quite like the way that some of the kind of tooling around it works. I'm quite a big fan.
JSON is valid YAML as well, isn't it?
Yes, I think so, which is even
nuts.
madder. Yeah.
But yeah, I think what I really like about the Swagger Open API stuff is all the tooling around it. So once you've got this Open API spec, you can actually generate documentation with a little demo thing in. You can your IDE can understand it, and you get little hover over prompts and stuff.
Yeah.
You can just get a lot of nice stuff for free. You can even generate SDKs.
Yeah,
which is pretty cool.
One of the best examples of that early kind of playground that I saw was Facebook. They had some really nice tooling around their APIs initially, and more recently it's become the kind of open graph playground or whatever they call it, where you can start to mess around with that. But yeah, all that sort of tooling that gets people interacting with your API and showing them the correct way to use it is really powerful.
Yeah, definitely. Some other tooling that I quite like that wasn't on my notes, but I'm just going to go off on a bit of a tangent. But there's a Mac app called Paw, which I really love.
Paw,
P-A-W, like...
I thought you said Paul.
Paul, yeah, it's called Paul. All right, Paul. But I really like this for reverse engineering stuff to play around with it.
Yeah.
So in your browser, you get copy as curl. So if you go in the network tab, you can right-click on the API request that it's made, copy as curl. You can paste into Paw,
right?
And it'll fan it all out into nice little tabs. It's like beautifully designed.
Oh, nice.
Mac app. I think one of the speakers that was at Alder Hazen are working for the company that makes it.
Oh, really? Wow.
I can't remember what her
I'm
name
going to have
was.
to look into that.
But anyway, you can tap into the body, the auth, the options, headers,
nice.
Play around with it. You've got a little request response thing, and you can build up your own documentation.
Oh, cool.
And then you can export it as C#, Ruby, JavaScript, and it'll just make you a little code snippet.
That's really cool.
With all the variables in.
So it's like, I don't know if you've used Postman for Mac. It's like that, but on crack, basically.
Yeah, it's the main advantage of this is that it's really good at taking in stuff that you've imported and chucking it out in different formats.
Nice.
But I think Postman's only recently added that, and it's never been quite as robust for me, but I don't know, maybe it is now.
It was always just a kind of API request creation tool, wasn't it, or things like that. Not to discredit it, but yeah, I think it sounds like Paw's something worth looking at.
Yeah, definitely. And then you can export it as Swagger and stuff if you want.
Great.
But you're not really design. I would design an API in Paw. I haven't really thought about it. I tend to just use it for tinkering with stuff.
Yeah.
And a lot of the time I'm debugging something or I'm coming into something fresh and something weird's happening. And I just want to play around with the request. Yeah,
that's. I think it's quite a fun way to start to discover things as well. It's a good exploration mechanism as well.
Definitely.
And it's good if the API tells you that you're trying to play with it wrong. Like if something's not working, it's good to get that kind of hint from the API.
Yeah, sometimes you just get a 500 with nothing in it.
Yeah.
Or worse, a 200 with an error in it.
Yep.
Because then the code you're calling it from, can't use your try-catch stuff.
Yep.
That's another thing about API design. Your status codes need to be good.
Yeah, they're hugely important. Spending time making sure you're returning the correct codes with some useful error messages, or particularly one thing that people get wrong quite a lot is if it's a JSON API, for example, not providing enough data in the error response for you to actually do something sensible with it.
Yeah, definitely. Something that Laravel does out the box, which I hate, is you've got an API, and sometimes if you don't pass in certain stuff, it won't error. It won't give you the right error message. Like if you don't put content type application JSON, it won't give you JSON. It won't give you anything. It's like, why do you do that? Maybe they fixed it in the latest release, but yeah.
Is that because it's like hitting the middleware before it even gets to the controller action or something like that? Or?
It must be, yeah. But yeah, just better default errors out the box would be good.
Yeah. Well, as you're saying about that rate limiting, if you're not giving developers, users of the API, hints on what's going on, people are just going to keep using it incorrectly, or in the rate limit example, just hammering your API and probably taking more services down possibly.
Yeah, definitely. Oh, there's another API that I hate. I won't name them, but they return a 201 and they have assigned a special meaning to that rather than putting it in the payload.
Oh, wow.
And it's something that you could easily miss. But it's a difference between one entirely different workflow and another.
Oh, right.
And it's a payment gateway, and I hate it.
Okay.
I'm sorry if you're listening.
but if you could just fix that'd be fantastic.
Yeah, just put it in the response, maybe.
Yeah, I think that's, it's all about context, isn't it? So in some areas it might be more efficient to return just a header, but you need to provide the information in that. There might be a special header that's telling you what's going on, or it doesn't have to be in the response necessarily, but you have to say what's going on.
Yeah, definitely. like, I don't think 201 has any particular. What's the meaning of a 201? I'm going to Google this.
I thought 201 was created, but I might be wrong.
201 is created.
Yeah.
Created success. Yeah.
It sounds like it wasn't doing that.
They'd return that if you need to do 3D secure.
Brilliant. Yeah.
Which doesn't make sense.
Yeah. I mean, what have you created at that point apart from a big problem?
A big problem.
Yeah.
Yeah. A horrible iframe with some other bank's gubbins in it.
Yeah.
But yeah, there are some horrible APIs out there.
3D secure in its entirety is a horrible thing.
I don't understand why they've just gone against everything that's sensible. So you can't see the padlock. You can't see where it's from.
No.
It's an iframe.
Yeah.
It could be any phishing site.
It's one of my favourite things recently is that Monzo have just gone, no, we'll just put a fake thing there for now and just deal with it properly in the app. And just be like, just go to the app and sort this out. We'll have you moving on quickly.
Yeah, we've sent you a push notification.
Yeah.
That's a nice way of doing it.
It's
then
nice.
You're not putting potentially private. I remember you used to have to like put your whole postcode in.
Oh, it's horrendous, wasn't it? Yeah.
Like letter one of your memorable thing. And
my favourite part of 3D Secure was when you hadn't set it up, and for the first time, as it's asking for the authorization, it asks you to register it.
Yeah.
How is that secure?
And you've got a little mini registration form inside, and you're on mobile, and you're trying to buy something that you don't want to buy anymore. I hate everything.
just end. Abort the whole process. Yeah. But that's a good example of where API design goes to serious loss of revenue because people hate it.
Yeah, definitely.
So yeah. So is there anything else that we've missed around APIs? I feel like we've covered quite a nice selection of things from history to features.
I think there's loads. I think one thing I'd say around pagination maybe is that the best pagination APIs I've seen, they give you, if they're cursor or offset based, they just give you the URL of the next one. So you can write a really simple while or your code just becomes way simpler then because you don't have to think about their implementation. And you can then change your implementation underneath if you need to.
Yeah.
If it's page 1, page 2, page 3 to begin with, and then you realise that the way your database works, you might have to change that to a cursor or whatever.
Yeah.
It doesn't matter. Cool, thanks Josh. That was a good chat around API design. Thanks for joining us on Off Script. Don't forget to hit subscribe.